If Mission Shakti is being discussed, then we will discuss Gaganyan. Okay, these are some of the topics left. Then we will discuss 5G technology. That one more quantum supremacy. And after that, we'll discuss something called this genomics. In genomics, I'm going to discuss with you Genome India project. And Indigene project. Okay. After that, we can discuss GM mosquito. Okay, and once this discussion is completed about genomics, we'll move towards GM crops. In GM crops, we can talk about BT cotton. Then we can talk about GM rice, golden rice, transgenic rice. Then two important pieces of legislation: Protection of Plant Varieties Farmers' Rights Act 2001 and Indian Patent Act 1970. Once this is done, this is the mandate for today's lecture. So let's start our discussion. So here the first thing is antimatter. So what is antimatter? Why we are talking about it? All that is important to be discussed here. See, antimatter, there is a project called Large Hadron Collider, LARG, large, GE large, hadron, HADRON. See, hadron is a term which is used collectively for proton and the neutrons. So when you must have heard that on the border of France and Switzerland, there is a project which has been going on with the name LHC, that is Large Hadron Collider, which is nothing but a 27 kilometer long tunnel, 100 meter below the surface of Earth. And in that tunnel, what they had done, basically, they had used superconducting magnets and particle accelerators. Okay, the particle accelerators, the machines which are used for accelerating the particles, isn't it? Fine. So basically, this project is which is regarded as the biggest experiment in the field of particle physics, is looking to answer three specific questions. Question number one: how the origin of mass took place. Origin of mass means MASS, mass. To explain the origin of mass, they have used the concept of Higgs boson. So Higgs boson, which is famously known as God's particle, is responsible for the origin of mass. Second question which they are looking to answer, which I discussed in the previous class: what is dark matter and dark energy? Okay, did I discuss that? Yes, we discussed it. And third question which this Large Hadron Collider is looking to find out the answer is: when the universe came into existence, okay, matter and antimatter were in equal proportion. Means if there were 1 trillion atoms of hydrogen, there were 1 trillion anti-hydrogen. But the question is, today we do not find that antimatter. Why? So here the question is not what is antimatter. That question is very well settled. There is no doubt about it. The question is where that antimatter has vanished. Got that point? Okay. So now let's start this discussion on antimatter. See, basically antimatter is formed by antiparticles. Okay, so what is antiparticle? Antiparticle is something which is having the same mass but opposite charge. So basically antimatter is formed by what? Antiparticles. What is antiparticle? Same mass but opposite charge. So going by this logic, electron, the antiparticle is positron. For proton, it is antiproton. And for neutron, it is anti-neutron. Okay, now some of you will be having this question suddenly, as if you would have been sitting across me in the classroom, that sir, how come neutron, anti-neutron can be there because neutron do not have any charge? You are absolutely right. Even for a second I am not suggesting that neutron is having a charge, but in case of anti-neutron the condition is it is having the same mass but opposite direction of the magnetic moment. Magnetic moment, actually neutron has got a very small, feeble, weak magnetic field. Okay, got that point? Okay, so magnetic field is a vector quantity. Okay, so in case of anti-neutron, the mass will be same, but the direction of the magnetic moment will be opposite. But the direction of the magnetic moment will be opposite, so they form what we call as antimatter. Okay, these proton, antiproton and antineutron forms what we call as antimatter. Got this? Fine. So here they are saying that when universe came into existence, matter and antimatter were distributed in equal proportion, but today we do not find that antimatter. The question is why? So that is the question here. But again, besides this, antimatter is going to have lot of relevance as far as this theoretical and practical aspects are concerned. Theoretical aspects of antimatter research includes that it will help us in understanding the evolution of the universe, like how the universe has evolved over a period of time. Okay, but recently there was some news related to the synthesis of antimatter, like there is a lab in USA called Brookhaven lab. A Brookhaven lab has synthesized a nuclei of antihelium. Now what is helium nuclei? 2 proton, 2 neutron. What is antihelium nuclei? 2 antiproton and 2 antineutron. So if I write it, 2 antiproton, 2 antineutron, this is antihelium. But on the other hand, if I write helium, that will be 2 proton, 2 neutron, isn't it? So this is helium and this is antihelium. Besides that, there was a news regarding the synthesis of antihydrogen also. Now if I see antihydrogen, what is hydrogen? Proton and electron moving around it. Yes. What is antihydrogen? In place of proton you have antiproton and it is surrounded by positron. Okay, so positron moving around the antiproton is antihydrogen. Here you could have noticed one thing, all of you, those who have been watching this lecture, that the distribution of charge is opposite in case of matter and antimatter. How the distribution of charge is opposite in case of matter and antimatter? The distribution is like the antiproton in case of antihelium, negative charge, proton positive charge, proton in hydrogen positive, antiproton is negative, so they have the opposite charge. Actually, NASA is planning to use antimatter as a fuel for the future interplanetary mission, especially manned mission to Mars. They are looking to send human beings to Mars. Actually, the problem is when you are sending someone to Mars is that to go there, to stay some time and come back, minimum it will take 500 days. That's a big time. And the question here is not 500 days or 400 or 600 days. The question is whether human beings can survive for such long durations in such hostile environments. And there is a big question mark over that. We don't have a confirmed, you can say, an absolute answer whether it will happen or will not happen. So we are looking to reduce this duration of the journey, okay, from 500 days, whatever time we can cut down. Don't say sir 500 minus 1, that will not serve any purpose. For that purpose, NASA is looking to use antimatter as the fuel. Actually, their plan is matter and antimatter. Just imagine this right hand is matter, this left hand is antimatter. Distribution of charge is opposite, it is still there in front of you on the board, and as the distribution of the charge is opposite, they will attract each other. And because of the attraction, what will happen? They will come in contact with each other and there will be annihilation. Annihilation means the conversion of entire mass of matter and antimatter into energy. The energy produced from the annihilation of matter and antimatter will be many times more than the energy produced from the fusion, okay, which is the source of the energy of the sun and the star. But the problem here we are finding in case of sustaining antimatter is that we have not been able to sustain it beyond a fraction of a second. So fraction of a second, obviously antimatter existence will not serve the purpose. We need to sustain it for much longer duration, and that's where we are struggling. We means Homo sapiens are struggling, as you people must be aware of the fact that we in this case does not mean India. Okay, it is the entire humanity which is struggling to sustain it. But again, you must be having a question that what about the natural evidences of antimatter? See, as far as the natural evidences of antimatter is concerned, they are being few and far in between. There is a probe of NASA called Pamela, which has detected Pamela, P-A-M-E-L-A. Pamela has detected a sheet of antiproton which was trapped in the Earth's magnetic field. Okay, but that is only antiproton. It is not a complete atom of antimatter. Similarly, there is a probe of on International Space Station, AMS. Alpha magnetic spectrometer. This probe has detected some positrons over there, but again positron there, antiproton there, we don't know how like they came into existence and why we don't find the complete atom. Okay, fine. I hope you got the concept of matter and antimatter. Okay, thank you for this topic. Now we'll move to the next one, and the next one is the Mission Shakti. Mission Shakti. India has become the 4th country to successfully test anti-satellite missile. Wonderful. Okay, so Mission Shakti, if we see the sequence of the events, it's like this. Red use कर सकते हैं ना, कोई issue नहीं है ना? Okay, if we say Mission Shakti, light तो नहीं हो रहा है, हाँ? It's like this, Mission Shakti, the sequence of the events, or any other word which you want to attribute here. Okay, 4 countries, US, Russia, China and India have successfully tested what? Anti-satellite missile. Anti-satellite missile. Okay, fine. Wonderful. Now come, listen here. How it all started? See, 2007, China tested anti-satellite missile and they targeted their own non-functional remote sensing satellite. So they targeted their own. So what we did? In 2008, India created integrated space cell. Integrated space cell. Where? In the headquarters of Integrated Defense Staff. Integrated Defense Staff. The job which was assigned or ascribed to Integrated Space Cell was to ensure the safety of Indian satellites. Wonderful. Then 2010, we created a Space Security Coordination Group. This Space Security Coordination Group was headed by National Security Advisor. In those days it was Mr. Shiv Shankar Menon. Besides that, it was also having Indian Air Force, DRDO and NTRO, National Technical Research Organization. Okay, now National Technical Research Organization, it is the topmost technical spying agency of India. Okay, it is having many jobs. Okay, we are not discussing all of them. Just one is enough. Its job includes that keeping an eye on the launch of the satellites of the other countries. I'm talking about the technical aspects of those satellites. And another thing here is that it is also keeping an eye on the test of the missiles by the neighbor. So NTRO has 2 roles: keeping an eye on the launch of the missiles and the testing of the missiles and the launch of the satellites in the neighborhood, okay, and the other parts of the world as well. Then after that, 2018, one development which took place, Microsat R was launched, a satellite which was launched for DRDO. This is an optical remote sensing satellite. Optical remote sensing satellite, fine. And this was the satellite which was successfully targeted in 2019 by anti-satellite missile, by obviously using what? Obviously, it was successfully targeted by using anti-satellite missile. Now, an obvious question arises here. What is the range of this missile? Because this satellite was in the orbit of 275 kilometer. 275 kilometer was the orbit of this satellite. Fine. So, can we say the range of this missile is 275 kilometer? No, absolutely not. The range of this missile is approximately 1000 kilometer. Okay, so keep this thing in mind when you are appearing in your preliminary exam, that it is capable of testing satellite missile which can go up to 1000 kilometer or beyond that also. Fine. Now, let's move further. Like what happened after the testing of this missile? See, after the testing of this missile, we can obviously see one thing, that DSRA was created, Defense Space Research Organization or Defense Space Research Agency was created, both are same. Now, Defense Space Research Agency, you can say it is a fusion. So, chronology has been going on like this. This was the first one, this is the second part, and then this happened. It was created in April 2019. DSRA, you can say it's a fusion of ISRO and DRDO. What is the job? It will develop the weapons. For what? For a space warfare. To fight the space war, isn't it? That is the job of DSRA, in short. Then after DSRA, we created DSA, Defense Space Agency. Now, Defense Space Agency will be headed by the officer of the rank of Air Vice Marshal. Air Vice Marshal. It will have the headquarters in Bengaluru. Okay, and what is its job? Obviously, this agency will fight the war in space. So, Defense Space Agency will be fighting the war in space, and more importantly, it will be supported by whom? Defense Space Research Agency will support the Defense Space Agency over there. Then after that, we took one more decision, which I am going to write here. We planned first ever space warfare exercise, and that is known as SpaceX. Okay, so this has been the what we can say, the developments which have followed. Now, recently there was one more news, that we are planning Indian Data Relay Satellite System. Indian Data Relay Satellite System is like this, that this satellite, this particular system, we are going to have two satellites in geostationary Earth orbit, means these satellites will be GSAT. Okay, and one line, these two satellites or these satellites will monitor the possible attacks on our space assets, isn't it? So, that is what we are looking to achieve over there as far as this Indian Data Relay Satellite System is concerned, and these that is what we call as Mission Shakti. But then the question arises, like will it really serve the purpose to have anti-satellite missile? Actually, it goes this way. US, Russia, China, all three have abandoned the technology of anti-satellite missile. Rather, they have moved toward the next one, and the next technology they are working on is called high energy weapon or direct energy weapon, which is nothing but a very strong pulse of electromagnetic radiations which is released towards the satellite and will burn the main part of that satellite, and that satellite will become defunct. So, it will not break down into pieces. But well, that satellite will become useless. Okay, it's very much like this, that the chip has been burned. Okay, so we also need to work on that. Another aspect, another question which arises over here is that these three countries have worked a technology called orbital maneuvering. Now, orbital maneuvering, MANOUVERING. In case of orbital maneuver. In case of orbital maneuvering, once they feel there is a threat to their satellite, they move their satellite to the higher orbit. Okay, with that also obviously India need to work very seriously. in order to protect its space assets. No doubt, no doubt. The test of anti-satellite missile has provided India the capacity called space deterrence. Space deterrence means which will be on par with cyber deterrence and nuclear deterrence, and in future any country which is having nuclear deterrence, cyber deterrence and space deterrence can obviously ensure that one thing, that it is going to call the shots in case if there is any conflict anywhere in the world. But one more point we need to keep in mind is this: what is the future for Defense Space Agency? In future, Defense Space Agency will evolve into Space Command, and a Space Command is defined as the fourth domain of the warfare. Okay, so what we are looking to do, we are creating three specific commands. One is a Space Command. We have a Strategic Forces Command for the nuclear weapon already in place, and the next one will be Cyber Command. Cyber is known as the fifth domain of the warfare. Space is known as the fourth domain of the warfare. Got this? Okay. So this was my humble effort to discuss Mission Shakti. We'll discuss one more and then the space module is done. That is Gaganyan. Gaganyan. See, Gaganyan, what is our plan? 3 crew members in an orbit of 375 kilometers for 7 days, and then we'll bring them back. Okay, and the name we have given to them is Vyomnauts. What is the meaning of Vyom? Vyom means air and space. Okay, so like China has taikonaut, US had astronauts, Russia has cosmonauts, so India is looking to have the Vyomnauts. Okay, fine. The question arises here is, what are the steps which are required to conduct a manned space mission? Okay, what are the requirements of that? The first and foremost is, first requirement of any manned space mission is rocket. No doubt, we are looking to use GSLV Mk3 here, which is obviously by far the most powerful launch vehicle we have. But GSLV Mk3 was not designed obviously to carry human beings into space. Primarily, it was designed for launching the satellites. Sending human beings into space is a different ball game rather than launching the satellite. So therefore, obviously, ISRO needs to have at least 10 flights of this particular launch vehicle before the actual mission takes off. And obviously, these 10 flights will obviously result in human rating of this vehicle. Human rating means modifying the vehicle as per the human space flight requirements, isn't it? That's not a big deal for ISRO. We are in 2020, 21, 22. Okay, 3 years more than enough for having the 10 flights of GSLV Mk3, not a big deal. Second one, which is vital. See, everything is vital. Okay, re-entry technology. Re-entry will decide the outcome of Gaganyan, which way it will go. So, sir, how come re-entry? Is simple. Re-entry will decide in this way. As of now, we have conducted 3 re-entry experiments and all of them have been successful. How can I say that? I can say that on the basis of these 3 facts. First experiment ISRO performed in case of re-entry. Re-entry means bringing it back. Is called SRE1, Space Capsule Recovery Experiment 1. Now, Space Capsule Recovery Experiment 1, what ISRO did? They took a 600 kilogram capsule which was placed in a 600 kilometer orbit around the Earth. Okay, wonderful. And there was no human being, nothing inside, and then for some time it was made to move around the earth in a circular orbit, and then it was instructed by ISRO to return, and it returned and returned successfully. The purpose of bringing it back was to test the navigation and guidance during re-entry, and eventually it is splashed into Bay of Bengal, means it fell into Bay of Bengal. It was deliberate, intentional, purposeful. Okay, so it was not accidental, but the best part was it remained intact. It was one piece, there was no disintegration, nothing like that. So this is a space capsule recovery experiment 1. Second experiment which ISRO performed is called CARE. CARE is Crew Module Atmospheric Re-entry. Now Crew Module Atmospheric Re-entry is Hindustan Aeronautics Limited has designed the capsule which will be used for Gaganyan. So ISRO took GSLV Mk3 with passive cryogenic. Passive cryogenic means it was not supposed to switch on, and on that passive cryogenic GSLV Mk3 they placed the capsule. Okay, it took off, reached 126 kilometer. There this capsule detached, okay, had a free fall about 70-80 kilometer. Then it followed a parabola to return. Okay, so this is known as Crew Module Atmospheric Re-entry experiment. Third was testing of the prototype of RLV. RLV, reusable launch vehicle. In the last class, first class, I have discussed with you. So here what ISRO did, they took a 2-stage solid fuel sounding rocket, and on that 2-stage solid fuel sounding rocket they placed the prototype of RLV. This sounding rocket, which is called Rohini, carried it all the way to 70 kilometer. At a height of 70 kilometer, this prototype detached, and after following obviously parabola, it crashed into Bay of Bengal. So this was the prototype of RLV. These are the 3 experiments for re-entry ISRO has performed till date, and the best part is all 3 have been successful. Then the third step which is required for conducting the human space flight is called Pad Abort Test or Crew Escape System. See, Pad Abort Test is something like this. When the mission is going upwards, you never know, vehicle might develop some glitch, or the capsule might develop some technical snag. Okay, so in that case you have only one thing in your mind, how to evacuate, isn't it? So for the purpose of evacuation of the crew members, if anything untoward happens, like if some emergency situation develops, that is what we call as Pad Abort Test. It was performed in July 2018, and in August 2018 what happened, this thing that the announcement for the Gaganyan mission was made. That is requirement number 3 as far as Gaganyan is concerned. Fourth is human rating. Human rating of the capsule and the vehicle, both. Okay, this is where by 2020 obviously that humanoid, half humanoid robot called Vyomitra will be used. Okay, so this robot will be placed in that capsule, will be sent into space. Okay, or maybe this will happen this year, okay, 2020, and this is where we will see what all challenges this mission will encounter, and in response to that we will modify them. That is what we call as human rating. Fifth requirement is called environment control life support system. Now environment control life support system is like this, that when 3 people will be there in such a small space like my podium is, and that too for 1 week, the thing is humidity will shoot up, temperature maintenance will be an issue, carbon dioxide level will increase, oxygen level will decrease, radiations will be coming from outside. So, environment control life support system, the purpose is how to sustain the life supporting conditions inside that capsule by removing carbon dioxide, by blocking the radiation, by maintaining the temperature, etc., etc., etc. That is environment control life support system. Then the sixth requirement is astronaut training. Astronaut training. As you must be knowing, there have already been like 4 crew members of Indian Air Force fighter pilots have already been undergoing training at Yuri Gagarin Center in Russia. Once their 1-year training is done, then they will be obviously made to undergo training in Paris and Bengaluru. And once these 3 training phases completed, then 3 out of these 4 people will be sent into space. Then that's what we are looking to do under Gaganyan mission. Wonderful. So these are the 6 requirements of having human space flight: rocket, re-entry technology, pad, abort test, human rating, environment control, life support system, and 6 is astronaut training. Okay. Now the question arises, why we are doing that? What is the purpose of doing such projects which will cost us around 10,000 crores? See, this project is just the beginning. First positive impact of this will be India's space station. Without human space flight, a space station is useless thing, because who will be there in that space station? Basically, space station is for supporting, obviously is for training the crew members. That's point number 1. Sir, why we need to have a space station? See, space station will serve 2 important purposes. First purpose space station will serve is training the crew members for the future interplanetary mission, and another purpose it will serve will be this, that we can use it as a launch pad for the future missions. Okay, for the future missions means Moon, Mars, wherever it is. Another aspect of human space flight is it will help us obviously to work out something called space mining. Okay, space mining is something which is going to determine the future of space exploration. You know, all the major powers, space powers in the world are having the project for something called space mining, that is to bringing the samples from outer space to Earth. Okay, so that is the reason India was looking to perform Chandrayaan-2. Okay. And if you see, China is also having moon mission, US is also having moon mission, so on and so forth. Okay, but why everybody is looking to go to the south pole of the moon is a question, because see, south pole of the moon is important for the reason that frozen water has been discovered on the pole of moon. Frozen water has been discovered. So if this is moon, okay, and here you have craters, this is crater, this is crater, and as you know, the moon is not tilted on its axis like the earth is. And if this is sun, common sense, this sunlight will never reach the pole. Pole sunlight will never reach. So if sunlight will not reach the pole, the temperature will be lower, and if temperature is lower, water will be frozen. Okay, there will be no liquid water over there. So that is why everybody is looking to go to moon south pole. One more reason why countries are fighting, or obviously not fighting, competing with each other to go to moon south pole, because here are mountain peaks. Okay, and the peaks of these mountains receive sunlight throughout the year. And we call them peaks of eternal light. Peaks of eternal light means almost throughout the year. So the plan is, on these mountain peaks have the solar panels. These solar panels will produce the electricity which will be used to take out the water and break down the water to produce hydrogen and oxygen. Okay, so basically this moon south pole will help us in having the water for the thermochemical decomposition, which can be used as a propellant for the deep space missions. So we will send a mission from here to moon. Basically it was meant to reach Mars. On moon we will fill it with hydrogen and oxygen and send it to the Mars. So basically moon will be used as a launch pad for the future missions. The reason being the gravity on moon is on the lower side, and lower gravity means lower consumption of the fuel. Okay, but then there is one issue also. What is that? All the major powers are looking to go for a space mining. Like 2020 China is having a mission to bring helium-3 samples from moon. Now helium-3 will be used for in fusion power project. Okay, now fusion power project helium-3 will be used because it is not found on Earth. And space mining goes against Outer Space Treaty 1967. Outer Space Treaty 1967 says outer space shall be the province of the mankind. Means all the countries from US to Uganda have equal rights over it. Fine. So then the question here is whether Uganda will reach the moon obviously in near future. No. By the time they will reach moon, the resources have been exploited by the other countries. Another question, another issue here is Outer Space Treaty 1967 says outer space is not subjected to national appropriation. National appropriation means you cannot carve out the territories in deep space like you have carved out the territories on Earth. Okay. But when countries will be carrying out space mining, don't you think there will be de facto recognition of the territorial rights? Like if US is doing mining here, China is doing there, India is doing there. So that means that is Indian territory, that is Chinese territory, that is US territory. Obviously, is it not de facto recognition of territorial rights? Answer is yes. One more point Outer Space Treaty is having, there is no dispute resolution mechanism. If anything happens between US and China, obviously the conflict in deep space, there is no mechanism to resolve that dispute. So the issue here is that from being a technical thing, it will become political and legal in nature. Therefore, it is an urgent need to have Outer Space Treaty 2.0. Okay, so that is what the requirement is. This was Gaganyan mission. I hope I have been able to give you the concept. Now we will be starting the next topic, that is what we call as GM crops, biotechnology. No, after this 5G technology we will discuss, quantum supremacy we will discuss, then we will start the GM crops, okay, and the genomics. And if that is being discussed, then lecture number 2 mandate is over, then we will start the lecture number 3. Next is 5G technology. See, 5G has been described as general purpose technology. General purpose technology like electricity. Like electricity is omnipresent. Obviously, tell me one thing, one technology which can work without electricity. Obviously, broadly speaking, if you can give me some exception, that's always fine. Similarly, 5G will be the basis of driverless cars. It will be the basis of what we call Internet of Things. It will be the basis of Industry 4.0. That is what we call as 4th Industrial Revolution. Okay, so without 5G, these 3 things will be useless. Okay, and if these 3 things are useless, then no future technological evolution will be possible. Now 5G actually, what are the requirements of 5G? The requirement of 5G is speed will be 100 times the speed under 4G. That's wonderful. Second requirement, latency will be 1 millisecond. 1 millisecond, obviously that's wonderful, but otherwise there will be too much of buffering and the driverless vehicles won't work. Then 99.9% of the territory will be covered. Okay. Now besides that, one very important requirement is a spectrum. Means the frequency which will be used. For deciding the frequency, for 1G, 2G, 3G, 4G, there is a body called International Telecommunication Union, and this International Telecommunication Union organizes World Radio Conferences. Okay, this World Radio Conference has identified two frequency range 1 and frequency range 2 for 5G. Frequency range 1 is up to 5 gigahertz and frequency range 2 is from 24 gigahertz to 100 gigahertz. Okay, these are the two options which are available. Countries can opt for any of the two frequency ranges. We have decided, India has decided to opt for frequency range 1, where US has decided to opt for frequency range 2. Okay, wonderful, there is no problem with that, both the options are equally valid. In frequency range 1, India has decided to allocate frequencies from 3.3 gigahertz to 3.6 gigahertz, that is 300 megahertz frequency. See, that will be allocated. Now, out of this 300 megahertz, 25 megahertz is for space and 100 megahertz is for defense. Now, how much you are left with? You are left with 175 megahertz. So that's a very important question, because for 5G services you need proper bandwidth, and one operator on an average require 100 megahertz of frequency. As we all know, we have three operators: Airtel, Vodafone Idea and the Jio, isn't it? So 175 divided by 3, in my arithmetic, it is not 100 megahertz, it is not even 60 megahertz, it is less than that. So if we are not having proper bandwidth, so is it possible to have quality 5G services? I think no, that's the answer for that. But another issue related to spectrum pricing is spectrum pricing of 5G. What is that? TRAI has come up with a basic price of 492 crore for 1 megahertz of the frequency in 3.3 to 3.6 gigahertz. Now, if an operator has to pay 492 crore for 1 megahertz, now 100 megahertz is simple arithmetic, will be close to 49,000 crores. That's just for buying the spectrum. And given the fact that 2 out of 3 telecom operators in our country have reported massive losses, huge losses. So is it possible for these operators to shell out 50,000 crores approximately only to buy the spectrum? And what about the remaining infrastructure which they need to create? What about the investment for that? Are they in a position? I don't think so. They are in a position to do so. So first is bandwidth requirement, second is the pricing issue, third issue in 5G is the involvement of Huawei, Huawei. Huawei, obviously, why it is an issue? Because it's a Chinese company and it is known for its proximity with the China government. Moreover, China has 2 laws of 2014 and 17. These laws have mandated that it is compulsory for the companies of China to share the data with them, whichever data they have been asking for. Now the question here is, when 5G will be such a pervasive technology, it will be there in our life like oxygen is, isn't it? Now, will it not be possible for Huawei to collect all types of possible data? Okay, that is one very serious question which needs to be answered before we allow Huawei to participate in 5G. Moreover, Huawei has proposed that they will give line of credit to our struggling telecom companies. That means that will increase the dependence of our telecom companies for their finances on Huawei, which again raises certain questions over there. One more thing is that what about the indigenization of technology? As far as indigenization of technology in 5G is concerned, Department of Telecommunication has sponsored a program called 5G Technology Demonstrator in IIT Madras. and IIT Madras involved Indian Institute of Technology, Hyderabad, and Indian Institute of Science as well. And obviously they used most of the indigenous technologies to obviously demonstrate 5G technology over there. But for some reason this project was not further extended, and now we will be dependent on the imported items as far as 5G is concerned. Okay, so these are some of the things associated with 5G. These are some of the issues. You need to remember this for preliminary. Okay, frequency ranges, etc., etc. Okay, now the next topic which I am going to discuss with you is quantum supremacy. Okay. So quantum supremacy. As you must be knowing that recently Google demonstrated a calculation by using their quantum computer, and that took 200 seconds. It took 200 seconds to perform that calculation, which Summit 3, which is the fastest supercomputer of IBM, will take 10,000 years. 200 seconds versus 10,000 years. That's amazing. So, and basically it is nothing but quantum computing. So what we are looking to achieve in quantum computing? See, quantum computing, the purpose is to replace modern days supercomputer, the supercomputers we have, with the desktop sized computer. Means supercomputer replaced by the desktop sized computer. That is what we call as quantum computers. Okay, but then quantum computing, what we are looking to achieve? See, in quantum computing we will be using obviously individual atoms, ions, molecules, photons. For what? For the storage of information. Okay, and retrieval of the information. But these atoms, ions, molecules are in a supercooled state. Supercooled state means the temperature which is slightly above the absolute zero, slightly above absolute zero. Fine. So that's where we are using individual atoms, ions, molecule to store and retrieve the information over there. Basically, quantum computing is based on quantum mechanical model of the atom. Okay, actually there is quantum physics and there is Newtonian physics. Quantum physics is probabilistic in nature. Quantum physics is applicable on individual atoms, ions, molecules. Okay, one atom, one ion, one molecule, one electron. When we are trying to study, that is what we call as quantum physics. Whereas Newtonian physics is deterministic in nature. Okay, macro objects. When you are studying about this desk, that is Newtonian physics. Quantum physics is probabilistic. Probabilistic, just recall the definition of the orbital. The place we are finding the electron is maximum. Probability of finding the electron is maximum. That is what we call as quantum physics, probability. Newtonian physics is deterministic. It means regarding this chair, you can say with certainty that this chair is immobile, point number one, and these are the coordinates of this chair, x, y, z. Okay, so that's how the quantum physics work. Okay, so quantum physics, individual atoms, ions, molecules. Newtonian physics, macro object. Quantum physics is probabilistic in nature. Newtonian physics is deterministic in nature. Okay, now quantum computer, basically quantum physics, as you must have read about quantum numbers, that is one example of quantum physics. Heisenberg's uncertainty principle, you must have read that you cannot simultaneously determine the position and the momentum of the electron, that is also quantum physics. Okay. Then Schrodinger wave equation. Okay, don't say that you were able to understand. Don't lie. Even virtually, you should not lie. You only mugged it up to forget it on the day of the exam, isn't it? So, yes, you're laughing. That's fine. But that's how the concept works. So, quantum computing. Whenever you are looking to attempt a question, the commerce and the humanities student, just remember 3 words: entanglement. So, quantum computing is based on 3 terms. Entanglement, second superposition, and third is qubits. Just look for these 3 terms, you will be able to solve the question. Entanglement. Focus on the dictionary word or meaning of the word entanglement. See, entanglement means bringing 2 quantum entities, say this is photon and this is an ion, bringing 2 quantum entities close to each other like this. And once you have brought them to a certain distance from each other, a pairing takes place. They get binded with each other, okay, roughly speaking. And after that, you can take them to any distance. Any means any, I can only take them to this far. Then if you know the state of this one, you can predict the state of this one. Getting it? If you will influence this one, that influence will be reflected on the other one also. This is what we call as entanglement. Entanglement will have application in quantum clocks. Quantum clocks will replace the atomic clocks. And people say if a quantum clock would have been switched on at the time of Big Bang, then by now the error would have been just of 5 seconds. That's wonderful. 5-second error from Big Bang till this date, it cannot get better than this. It will have application in quantum computing. It will have application in encryption. Entanglement will have the application in encryption, quantum encryption. Just remember the first class we have discussed about Indian Neutrino Observatory and all that. Second is superposition. Now, superposition is the possibility of a particle existing in 2 different states simultaneously. The possibility of a particle existing in 2 different states simultaneously sounds weird, absurd. For example, the possibility of an electron existing in low energy and high energy states simultaneously. Now, to explain superposition, Schrodinger, Schrodinger, Schrodinger used cat in the box paradox, CAT, cat in the box paradox. What does that mean? By that he meant, look sir, there is a box and in that box I have placed a cat and I kept a poisonous material in that box and that box is sealed. Now, till the time the box is sealed, closed, both the possibilities exist. The cat could be dead or the cat could be alive. That is what we call as superposition. Getting it? So, superposition is the possibility of a particle existing in 2 states simultaneously. Okay, getting it? Now, superposition is the basis of qubits. Qubits are quantum bits. See, in case of normal computer, the capacity is expressed in binary. Binary means 0 or 1. Okay. But in case of quantum computers, we use the capacity called qubits or quantum bits, and the capacity is expressed as 0 0 plus 1 0 plus 0 1 plus 1 1. So, for 2 qubits there are 4 possibilities. For 3 qubits there are 8 possibilities. So, basically the capacity of a quantum computer will increase exponentially, 2 raised to the power n. Okay, that is what we call as quantum supremacy. Just one more point. Where will be the application? See, the application of quantum computing will be in big data analytics. Big data analytics nowadays is a very common term. used in almost every context where the huge volume of data is involved. Okay, so this was my humble effort to discuss quantum supremacy with you. Is GM crops, and in GM crops, first I am going to discuss with you is BT cotton. Okay, see what is GM? GM is genetic modification. What is genetic modification? Changing the genetic makeup. What do you mean by changing the genetic makeup? See, this is DNA, and what I did, I removed a certain part of this DNA modification. See, this is one DNA, and what I did, I add another DNA to this modification. So adding a part to the DNA, modification, removing a part from the DNA is modification. So then there is a term called genetic modification, and there is a term called transgenic. See, genetic modification is like when it can be done within the species and across the species also. Like gene from one human being into another human being, it is genetic modification. But transgenic is that genetic modification where the gene is transferred from one species to another species. So when you are transferring a gene from one species to another, that type of genetic modification is what we call transgenic. It could be plant as well as animal. Very famous example of transgenic is liger, when gene was transferred from lion into tiger. Okay, wonderful. Another example of transgenic animal, spider goat, gene from a spider into goat. Great, keep it up. But when it comes to crops, the transgenic crops are multiple: BT cotton, BT brinjal, GM mustard, golden rice, GM rice, transgenic rice, terminator seeds, traitor seeds. These are all examples of what we call the transgenic crops. Okay, the most famous example being BT cotton. BT cotton, where BT stands for a bacteria called Bacillus thuringiensis. This bacteria is found in soil and is known for producing a toxin, and it is known for producing a toxin, and that toxin obviously was very much effective against the pest. So it produces a toxin, and that toxin was used as a pesticide. So what used to happen earlier, farmers will spray BT means Bacillus thuringiensis over the crop. This bacteria will produce the toxins, and then what will happen, that once the pest will eat those toxins, it will die. Okay, this is how it used to work. But with modern biotechnology, it became possible to transfer the gene from one species to another. So what we did, we took out a particular piece of the DNA of the bacteria. We extracted gene from the bacteria and transferred that gene into cotton. Consequently, cotton also started producing the same toxin, which was produced by the bacteria. This is how BT cotton is pest resistant in nature. Pest resistant in nature. BT cotton was allowed in India in 2002, and it is made available under the commercial name called ball guard. So ball guard is the commercial name of the BT cotton. So there is something called ball guard 1, which was permitted in 2002. It is pest resistant in nature. Then there is ball guard 2, which was permitted in 2006. I am talking about India. It is also pest resistant in nature. Then there is something called ball guard 3. It is pest resistant and herbicide tolerant. So this is the difference between the 1, 2 and the 3. India has permitted Bolgard 1, Bolgard 2, but there is no permission for Bolgard 3. This herbicide, the herbicide against which Bolgard 3 is tolerance is known as glyphosate. So, glyphosate is the chemical which Bolgard 3 is resistant, and glyphosate is sold under the name called Roundup Ready. So, Roundup Ready is the commercial name of glyphosate. That is why Bolgard 3 is also known as Roundup Ready Flax. Flax is also known as Roundup Ready Flax. In India, there is no permission for Bolgard 3 because it is herbicide tolerant. Okay. And one more point here is this, that in Haryana some farmers have gone for HT cotton. This is the HT cotton. Some of you might be having the question, sir, why it has not been allowed? See, it has not been allowed for the simple reason that the use of this glyphosate will result in the development of super weeds. Okay, super weeds means these weeds will not be very easy to eradicate. Moreover, this chemical glyphosate is carcinogenic, and Supreme Court appointed technical experts committee has also said that India should not allow the herbicide tolerant variety of the GM crops. So, this is Bolgard for you. Okay, you must remember what has been permitted, what has not been permitted. And American company Monsanto, which introduced BT cotton in India, has promised the resistance against 3 types of pest, that is pink worm, spotted worm, and the American worm, isn't it? So, this is the status. Today you must be knowing around 95% of the total cotton harvested in India is BT. That's a big number, and quite an alarming number as well. Okay, we stand 5th in the world in terms of GM crops under the in terms of area under the GM crops. Okay, so that is BT cotton for you. After BT cotton, okay, next one is golden rice. See, golden rice is a biofortified crop. What is the meaning of biofortified crop? See, the meaning of biofortified crop is the level of nutrients is on the higher side. Is higher. Okay, that is the meaning of biofortified crop. It has been developed by International Rice Research Institute, Manila. Manila has developed it. Okay, basically beta carotene, the purpose was, in case of golden rice, the purpose was to increase, to start the biosynthesis of beta carotene. Actually, what happens in case of rice, there is synthesis of beta carotene in the leaves, but not in the grain. Okay, but nobody eats the leaves of rice as far as I know. So basically we wanted that the beta carotene, which is synthesized naturally and normally in beta carotene leaves, should be synthesized in the rice grain. And for that purpose, what we did, we developed golden rice. In golden rice first generation, a gene was taken from the flower of daffodil. Daffodil is a very common flower, and the gene was transferred into rice. And another gene was taken from the bacteria Pantoia ananetis. This is a bacteria. So gene from bacteria into rice, gene from daffodil into rice. What we found Rice means rice plant, rice cell, and then the plant was developed. What we found that beta carotene was present where in the rice grain, but the level of beta carotene was very small quantity of beta carotene was there. So we wanted this beta carotene to go up. So that's where we developed golden rice 2 or golden rice second generation. Here beta carotene was less in quantity. So for that what we did, we took a gene from maize, from that gene was transferred into rice, and the gene was taken from the bacteria Pantoia ananetis, and gene was transferred into rice. This time there was multiple times increase in the levels of beta carotene. So Bangladesh basically has permitted golden rice 2. Why? Beta carotene, when it goes into our body, it forms vitamin A, and obviously vitamin A is a very important obviously nutrient. Now let me okay, complete one more aspect here, that is GM rice and the transgenic rice. See, GM rice has been developed by MS Swaminathan Research Foundation. Transgenic rice has been developed by National Botanical Research Institute based in Lucknow. Okay, here basically the purpose was to have salt tolerance. Here the purpose was reduce arsenic. Both the cases abiotic factor, abiotic. What they did, they transferred a gene from mangrove. Mangrove, you know, the plant which grows in marshy area, where? Into rice. Why? Which gene? The gene which ensures the survival of this tree into those salty water. Okay, here they transferred a gene from the fungus. Remember this, fungus into what? Into rice. This gene ensured the survival of this rice plant into salty condition. The gene from this fungus was good enough to reduce the arsenic content in the rice grain. This is transgenic rice, this is GM rice, that was golden rice. I hope you understood the difference. Okay. Now next one is Protection of Plant Varieties Farmers' Rights Act 2001. Protection of Plant Varieties Farmers' Rights Act. This law was passed by using the sui generis mechanism. Sui generis mechanism, which is a part of WTO. It is compliant with UPOV, International Union for the Protection of Plant Varieties. So it is compliant with sui generis and UPOV both. Okay. It was passed in 2005, passed in 2001, enacted in 2005. Okay, enacted in 2005. What is sui generis? Actually, sui generis is a mechanism of WTO which gave certain discretionary power to the member countries. By using those discretionary powers, the member countries can draft the laws to protect their indigenous intellectual property. Like in our country, farmers have used their intellectual capacities to develop various crops over thousands of years of time. Is that not intellectual property? Yes, it is as important an intellectual property as any other is, isn't it? So we also have a right to preserve to protect those intellectual properties. But as these indigenous intellectual property will differ from country to country, because indigenous intellectual property in India will be different from that Africa, and African one will be different from the Brazil one. So they gave discretionary power. So you feel like there is certain intellectual property in your country which is indigenous in nature, but WTO has not given enough protection to it. You can use these discretionary powers and obviously pass the additional laws. So by using those discretionary power, we passed this law, Protection of Plant Varieties Farmers' Rights Act 2001. Now this law has given Indian farmers right to seed, right to compensation. Now right to seed means Indian farmers has a right to use, reuse, sell, exchange, consume any seed, including the registered seeds. Why we use the word registered seed in our country, not the patented seed? Answer is very simple. Section 3C and Section 3J of Indian Patent Act 1970 have absolutely ruled out any patent for the seeds. Section 3C says anything living or non-living found in nature cannot be patented. Living or non-living found in nature cannot be patented. Okay, seed obviously is living, found in nature, cannot be patented. If there was any scope, which I don't think there was, then that was ruled out by Section 3J of Indian Patent Act. Section 3J says that neither a complete plant nor a complete animal nor any part of plant or animal is patentable. Neither a complete plant nor a complete animal or any part of plant or animal is patentable. Means you cannot patent a complete plant, you cannot patent a part of a plant. Seed is a part of a plant, so therefore cannot be patented. That's why in India we use the word registered seeds rather than the patented seeds. Got this point? So it says Indian farmers can use, reuse, sell, exchange, consume any type of seed, including the patented one. Wonderful. But they are not allowed to carry out the organized marketing. Organized marketing means 2-3 farmers came together and obviously they put the seal of a particular company and start selling on behalf of that company. That is not allowed, because in simple language that is piracy. Now what is right to compensation? If because of natural factors there is a decline in productivity, natural factor like drought, flood, cyclone, any natural calamity, if there is a decline in productivity, then farmers are entitled to have the compensation. That's good. Point number 3 of this law is that there is a provision called National Gene Fund. What is National Gene Fund? Basically, National Gene Fund operates under Protection of Plant Varieties Farmers' Rights Authority. This protection of plant farmers' rights and Protection of Plant Varieties Farmers' Rights Authority functions under Ministry of Agriculture. Remember this, Farmer Agriculture, and under that National Gene Fund. How does this fund came into existence? Basically, this fund came into existence like this. That say for example that a multinational company came to India, and that multinational company went for improving some endemic crop, and obviously after that they commercialized that improved version of that crop. So they can do that, we can permit them to commercialize a certain endemic crop of our country, but the thing is they will have to share a certain percentage of their profit with us. With us means India. And whatever the percentage of profit they are going to share with us will be transferred in National Gene Fund. And what is the purpose of National Gene Fund? So National Gene Fund, the percentage of profit that will be shared by that multinational company. Why that multinational company will share? Because they are using our genetic resources. Got that point? And listen. Then from this fund, farmers will be rewarded. Which farmer will be rewarded? The farmer who has saved a certain crop from becoming extinct. Got this point? So that farmer who has saved a certain crop from becoming extinct will be rewarded by using that fund. Is this clear? That is the concept of Plant Protection of Plant Varieties Farmers' Rights Act. Got this? Fine. Now we are moving towards genomics. See, in genomics, as I know you people have already been taught 3-parent baby, so that I am not going to discuss. You have already been taught CRISPR-Cas9, so I am not going to discuss that. I am just going to discuss Genome India project. And Indigene project. Okay, so Genome India project and Indigene project. Now Genome India, first one was Indigene project. This project is executed by Institute of Genomics and Integrative Biology. Institute of Genomics and Integrative Biology, which is a body of CSIR. Okay, so what they did, they took genomes of 1008 rural youths. Okay. Now, why rural youths? Because we wanted to have the original DNA, because in rural areas you will have the obviously the original inhabitants of that place. Broadly speaking, I will not go into that debate. And some of these youths have been given an ID, and obviously they can generate their password. And if they visit a doctor, for some ailments treatment, then the doctor can prescribe the treatment. By using the genetic information. So basically this Indigene project will initiate something called pharmacogenomics. Also known as personalized medicine. So basically pharmacogenomics is a combination of two words, pharmaceuticals and genomics. So the treatment of an individual on the basis of his or her genetic information is what we call as pharmacogenomics. Got this point? Okay. Now let's continue further. Pharmacogenomics and all that. Now a broader version of this project is called Genome India project. See, Genome India project, here we will take 20,000 genomes. 20,000. This will be executed by National Brain Research Center, which is a part of Indian Institute of Science, Bengaluru, plus there will be 19 other institutes also. These 20,000 genomes will be taken in two phases, 10,000 and 10,000. Fine. In first phase, we will collect the DNA of the people without any ailment or the illness, and then we will develop reference genome. Reference genome means common genome, which is obviously something common minimum found in all those 10,000 people, that is reference genome. Then in the second phase, we will have the genome of 10,000 diseased people. Then sir, so what? We will compare these 10,000 diseased people genome with the reference genome, and we'll try to find out where this individual's DNA is different from this one, so that we can find out the cause of the illness in them by comparing with the reference genome. And if you can find out the cause, you can find out the solution also. That's where we will be moving towards precision treatment. So here we will be moving for precision treatment. Yes, here also we can go for pharmacogenomics, no problem. And one more thing, here we can find out why in certain parts of our countries certain diseases are more common, which is obviously not the case in other parts of the country. So that is Genome India project, Indigene project. Okay, with that the biotechnology mandate is over. Now we are left with something called nanotechnology. So let me give you some brief sketch what I am going to discuss in nanotechnology with you people.